Thank you very much. Thank you. All right, everybody, welcome to the first ever Achievers Tech Talk. I'm Zach, and I'm a senior software developer here at Achievers. Just going to make this really short and sweet. We've learned a lot over the last 6 years in growing a company, especially on our technology side, and this is really our way of giving back to the tech community around us. Our first topic and our first talk ever is going to be on scalability and about our journey from Java to PHP, and I'm sure that's piqued a lot of interest, as is told by the turnout here today. So without further ado, our CTO, Dr. Aris Zakinthinos.
Thank you. As Zach, well, that's been move it away from my mouth, perfect. But I don't look like Britney Spears anymore. As Zach mentioned, this is the first ever tech talk, and our goals for these series of talks that we're going to do is all around giving back. We have gone through an amazing journey here at Achievers, and while I'm not going to bore you with all the details in this talk, I'll just touch on it so you get a sense of where we've been and where we're going and why we want to give back. The community, and not just in Toronto, but the open source community, the development community in general has helped us a lot, so we want to return the favor. So I will have an opportunity at the end for you to ask questions, and we also have most of our development team here this evening, so after the talk, if you want to grab one of them and have any questions on what we did, we are more than happy to share our pains and even our successes if you are interested in our successes or just our pains, either way. So a little bit about me. I joined Achievers in June of 2009. Prior to Achievers, I was the CTO of a company called ZipLocal. ZipLocal was an online Yellow Pages company. I left ZipLocal when they got sold to CanPages, which then got sold to Yellow Pages. When I left ZipLocal, we were hitting just over 1 million unique visitors on the site. When I started at ZipLocal, about a year and a half to 2 years before that, we were in the 300,000 unique visitors a month. So I've spent about 7 years worrying about scalability. How do you grow a technology team? How do you grow an infrastructure to get to a point where it can meet the objectives of the business? My academic background, it's boring, I just threw it up there so that you guys know. I have a PhD from the University of Toronto. I did postdoctoral work at Cambridge University in the UK. I was the Naval Research Labs postdoctoral fellow of secure systems there, and I have some totally awesome stories around what our military can and can't do. It's actually quite cool. Maybe another talk. So what are our goals? Goals here are very easy. We want to help you not make the same mistakes that we made. As we will see, there's a lot to scalability. There's a lot to think about. We went down some blind alleys. We tried a bunch of things that worked, tried a bunch of things that really didn't work. We want to just share with you. Are you going to get all the answers that you've ever wanted about how to scale an infrastructure tonight? I hope so, but I doubt it. This is just the beginning. We could spend hours talking about this topic. But what we wanted to do was give you a flavor of where we've been and where we are going. We also want to give you some practical advice. Most of you here are developers or architects, or I met another fellow CTO in the audience. We want to be able to have you go home, wake up tomorrow, go in, and hopefully affect your current organization. This isn't just about Achievers and a rah-rah story about Achievers. It's really about helping you get better at your job. So let me just spend 5 minutes telling you just who Achievers is, where we've been, where we're going. It won't take any more than 5 minutes. So what does Achievers do? Achievers is a rewards and recognition platform. We help companies build recognition programs to recognize great performance on the job, to recognize leaders in the organization, for managers to recognize their employees, for employees to recognize their managers. It really is about helping an organization achieve its goals. Part of that is also a points engine. So when you do something great, you achieve a goal, you get an allotment of points. These points can then be used to buy things in our online catalog. Our mission is to change the way the world works. So that's all I want to say about Achievers, but I will show you a screenshot of our homepage. So this is what it looks like. It should be vaguely familiar because it's social media-ish. We have a news feed, we have leaderboards, we have point balance, how many points I have, and just for reference, it's a penny a point. So if you move the decimal place over, I have $2,300 worth of points in my personal bank, and I could go into the catalog and redeem for something out of the catalog. Okay, so let's start. That's it. No more about Achievers. We'll talk technology for the rest of the talk. So let's start with some definitions. So when I say certain words, I want to make sure that we all agree on what those words mean. First, performance. So what is performance? Performance is a measure of how fast something happens. So when you say something is performing, you typically mean that it's going really quickly. And when you say something is not performing, you typically mean that it's going really slow. Scalability. Scalability is not performance. Scalability is the ability to handle a growing workload. The two are obviously related, but it is critical when you're looking at this that scalability is not the same as performance. You can construct a hyper-performing system that can't scale to save its life. And you can construct a system that can't perform and nobody would ever want to use, but scales like a dream. They are not the same thing. Now I want to address one of the religious topics. So let me show of hands in your day job. Are you a Java developer? A few? PHP developer? Okay. Good chunk. .NET, a bunch of .NET people. We have a mixture. So I see this question posed every once in a while on whether it's Stack Overflow or somebody writes a blog, and it's which language scales the best? Languages don't scale. They don't. To say a language scales is to not understand what scalability is. So if you ever find yourself in a discussion and the person says language X doesn't scale, I would just walk away. It's not a conversation you can win because you are not talking about scalability. You are talking about personal preference. You are talking about what the person knows. You are talking about biases. You are not talking about scalability. Now, there are benefits to languages and there are drawbacks, and we'll talk about some of those. But there is more. There is more to scalability. If all you were worried about was performance and scalability, as a CTO, VP engineering, lead architect, even a developer, you're not worrying about enough things. It's also important to understand, how does your team grow? You all want to work for successful companies. I'm sure most of you do work for successful companies. When I started, we had 4 developers. We currently have 18 developers, and we're looking to hire 12 developers by the end of September. We are growing. The ability to onboard these people, the ability to train them, educate them, have them understand the code base is as critical to the scalability of the organization than anything that can happen in the technology. It's not enough to have great technology if nobody understands it. So let's talk a little bit about our SaaS platform. So what is it? So our platform is a multi-tenant architecture. For people that don't know what that is we have one code base and one database. We currently have about 170, 180 customers. So these are our large corporations that use our software. We host all the software. And they all share the exact same code base, and they all share the database. Yes, we have controls to make sure one person's data doesn't see the other person's data. But ultimately, it is a multi-tenant architecture. We have a module-based platform. Every company can decide what features they want, and more importantly, what features, how they configure those features. So what they want and how they want them configured. So this has meant, as we've grown, we have lots of legacy configurations. What do I mean by legacy configurations? It's configurations that we would never do today, but because some customer is paying us a whack of money, we need to maintain that. So being able to handle all these legacy configurations is one of the goals of our platform. We have to maintain backwards compatibility. We can't just break things. We also have back-end processing. Our back-end processing of the orders that I mentioned that you can buy from the catalog, we handle millions of dollars a month in orders. They go out. We handle hundreds of thousands of emails go out through our back-end. All of this work has to be provisioned, it has to be handled, it has to be managed, it has to be audited. There is a large back-end infrastructure that has to be maintained for this system to work. Okay, so let's start talking about what did our architecture look like in 2009. It was, I would say, a fairly vanilla J2EE stack. Of course, we had Java, we had Hibernate, we had Spring, we had JMS, we had MySQL. Very, very vanilla. I don't think we were that exotic. We just had most of the standard technologies. So I'll tell you a little bit about architecture, but I just want to have a quick aside. Posted on Amazon's EC2 platform. Highly, highly recommend it. If you're a startup, managing your own servers is not worth your time. Are there problems with Amazon's EC2? Sure. But in terms of the value you get from running off of Amazon, there is no comparison. You can spin up machines when you need them. You can shut them down when you don't need them. The performance is pretty good. You have management consoles. The tools have come a long, long way, even from 2009. We just moved off of Amazon 2 months ago. And we moved off of Amazon for 2 reasons. Reason number 1, it was getting really expensive. So we moved to Q9 Networks. So we have a co-location facility at Q9. And our cost has dropped almost in 2. So cost was a big factor. Second of all, the I/O rates you can get on Amazon's platform are a fraction of what you can get if you have your own hardware. So saving money for more performance, that's just a win-win. CFOs love that type of thing. So back to the platform. So I'm gonna throw up our architecture picture. This is our architecture picture. Can anybody see a problem with it? I have presented this slide for 10 years. What's wrong with it? You know what? Nothing. It's a great architecture. It's wonderful. You got a presentation layer, you got business logic, you got database, separation, arrows going back and forth. It's awesome. So what's the problem? Aris, you just said there was a problem with it. Okay, let me show you a different view of the architecture. Let me give you the data center view. Oops. That's the data center view. Yeah, it doesn't look too good. So you're like, well, how do you go from 3 tiers, presentation, business logic, database, to one little lonely box in the data center? Because if you're, for the Java developers, you're sitting here going, but J2EE scales. It scales. Sure, it does. It does, absolutely. You will not get an argument from me that J2EE platform scales. But the devil is in the details. It is not enough to go and grab a J2EE book, say you have a presentation layer, you have a business logic layer, you have a database, and go, ta-da, it scales, bring on the traffic. It doesn't work that way. So let's meet the details, or the devil, depending on how you want to look at it. What was our problem? I can actually summarize the problem in the next slide, and it's just one problem. Scaling was an afterthought. Sounds so simple. Oh, scaling was an afterthought. However, do not kid yourself. If you're in the moment, business is coming through the door, what you have is working. Unless you force yourself to take a step back and think about what's going to happen in the next 12, 24, 36 months, you do not worry about it. You don't. And this is the same issue that I have seen in a bunch of companies that I've been in. I show up, the very smart crew of developers, I had a really smart crew of developers when I joined here. You ask them to draw an architecture, and they give you the first picture. And then you're like, okay, well, how are you going to scale it? And they're like, well, we have 3 tiers. Yeah, but if you haven't thought about those tiers, what does that mean? You have a problem. So by the end, we were on the largest EC2 instance money could buy. If we had money, we had 24 million bucks in the bank, we would buy more. We were stuck. We could not grow anymore. You cannot retrofit scalability. You cannot. You can try, and I can assure you that you will fail. And it's not that you're going to fail because, Aris, he's up there, he's saying he's going to fail, so I shouldn't even try. You should think about it. And you should think about it because the problem is very deep in your code. It's about the design decisions you made. It's about the little things. It's about the stuff that developers do every day. It is not about what the CTO has drawn on his whiteboard or what the lead architect has put on their whiteboard. That is not enough. It's about the decisions that the developer who's developing at 3 in the morning in front of the computer, it's those decisions that are going to make or break your scalability. It's going to make or break your company. And unless you have the right design philosophy, the right way of thinking about the problem, I believe you will not succeed. So what are the issues? It's only about 3 or 4 of them. So I'm gonna tell you what those are. Hopefully that when I go through them, you will not see your own company in any of these. But if you do, hopefully I'll give you some ideas on what you can do. First one is complexity. What's the problem with complexity? So let me define how I think of complexity. It's the title of this slide. Who doesn't like magic? I love magic. When I came here, we had, as I said, Java platform, and for the people that aren't familiar with AOP, aspect-oriented programming, it's the ability to insert hooks into your code to be executed before or after any given function. Okay, that's the simplest way of describing it. And the way you define those is you have a file that says, if the function signature matches this expression, then execute this code before the function or execute this code after the function. Okay. As an academic, AOP is brilliant. It is totally cool. If you don't know about AOP, I actually suggest you go read about AOP. It will change the way you view development as an academic exercise. As a CTO, gave me heartburn. Talk about the heartburn in a bit. The other problem, I call it, there's a pattern for that. It was the development team, to their credit, was trying to get better. And they were trying to get better by reading about design, reading through books, reading about blogs, reading about patterns. And patterns are something that every developer needs to know. But the number of times in my career where I've been in the office and we're going through a design, I said, oh, that's clearly the visitor pattern, or that's clearly a singleton pattern, I could probably count on 2 fingers. It's great to think about it. It's great to understand how you use it. But it's not a game. It's not, oh, let's see if we can put a pattern in here. It's about solving a problem. And if the pattern solves the problem, use it. But I'm willing to bet you that there's always something that's just a little bit off, and that little bit off is what's going to kill you. So the development team used patterns everywhere. So it actually was pretty easy to read the code because you go, oh, they're using the visitor pattern here. And then you take a step back and go, well, why would they do that? A simple for loop would have been fine. Do not gravitate to complexity. And we'll talk about why in about 3 slides. The other one is an overly complex object model. Object models are great. If you're not using objects to think about your code, that's a problem. However, if it gets to a point that exactly one developer in your organization understands it, you've gone too far. We had our access control system. I can honestly say, so I have a PhD in computer security, I've done postdoctoral work in computer security, I've looked at government security models, I have seen it all. Our security model was the most flexible, the most robust, the most Swiss Army knife security model I have ever seen in my career. And exactly one human being on this planet could tell you how it worked. It was so complicated. That is a problem. Okay, so let's talk about why complexity is bad. Number one, so the analogy that I gave to my developers is like day 3. It's 2 o'clock in the morning. The CEO calls me. Production is down. We're losing millions a minute. What are you doing? I wake up. I open up my computer. Oh, we have a nice stack trace. I'll go to the line of code. I'll comment it out. We'll deal with it in the morning. I don't understand what I'm doing. I'm looking at this code. There is magic. Functions are being called that I can't see. There is so much complexity, I have no idea why it died. So like every good developer, what do? You kill the process, restart it, and hope for the best. Dies again. Because you do not understand why it died in the first place. Complexity at 2 a.m. in the morning is not your friend. If you can't look at the source code, start at the beginning of the function, and get to the end of the function without going, wow, it called 47 different functions and there's 3 cut points in here, and oh my God, where's the XML file that defines what the hell this means? It's too complicated. It's way too complicated. So what does all this have to do with scalability? As you ramp your team, it's a problem. Complex systems are inherently difficult. They're hard to scale at the best of times. We have a clustered environment, so I'm sure you guys could have guessed that we have a clustered environment in our production environment. We have weird problems, totally bizarre problems. I'll tell you one of them that happened a couple of weeks ago. We have a form. We have lots of forms. The form gets submitted via a post request. Our server logs show that it shows up as a GET request. How can that? The internet doesn't work that way. How is it possible that a post request, I have developers, we're looking at the code, we use jQuery to do our Ajax library, we're looking at Ajax, we're like single stepping into, I wanted to single step an assembly into the browser. How is it even possible that this post, I can see the post request leave the browser. I can see it, But I can also see in the Apache log, it's a GET request. Where's the problem? Between the two. Yeah, between the two. We spent half a day to a day looking through our code base. Why? Because you had to convince yourself that the problem was between the two, that you weren't doing, there wasn't a code path that somehow did a redirect. There wasn't a code path that inadvertently dropped a cookie somewhere, so the server thought you weren't authenticated, so it redirected you back to the home page, and we have single sign-on with this customer, so maybe it redirected you back, and oh my God, it turned into a GET. What the hell's going on? I don't understand anymore. And we have a relatively straightforward code base. If your code base is complicated and you're trying to convince yourself that that post turned into the get somewhere between leaving a company and showing up here, I can't call up the CTO of a Fortune 100 company and say, your infrastructure is screwed up. It is, look, post, get. You know what's the first thing he's going to say? Fix your damn buggy product. I need to be able to say conclusively, it's not me. If your software is complicated, it's going to take you weeks to convince yourself. Weeks. You need simplicity. Clustered environments are hard. If your programs are complicated and you're spending time trying to understand, it gets harder. There's just too many things to worry about. The last thing you want to worry about is why something isn't working and trying to figure it all out. You're going to hit a wall. We hit a wall. Every company I've been in gets to a point where their architecture gets to end of life. It happens. It's not a bad thing. It's actually a great problem. It means your company's growing. If you never hit a wall, either you're a totally awesome architect, possible, or your company isn't growing very quickly so you can always keep up. If that's not the case, you're going to hit a wall. And when you hit that wall, you need to be able to understand why you hit it. And if you can't understand why you hit that wall, then you can't figure out what to do. It's as simple as that. And you can't forget about the people. When developers show up and you show them a code base and maybe your onboarding processes are better than ours, I'm not sure they could be worse, so actually ours aren't great right now. You give them the code base and say, go, write code, fix bugs, here's a feature, go build, tell me when you're done. Okay, not like that, but pretty close. If they can't pick up the code base and understand it, they can't be productive. And if they can't be productive, they're not adding value. If they're not adding value, they're not finishing features. If they're not finishing features, customers get mad. Customers get mad, CEO hears about it, you get fired. You have to ensure that the people can easily understand. And my final thought on complexity, complexity always increases over time. I have yet to work on a system where as we write code, the system gets less complicated. That would be a pretty amazing system. I haven't seen one yet. If you start at so much complexity that nobody understands, where do you go from there? You go into Never Never Land, where you're just hoping that nothing ever breaks because nobody can ever fix it. So let me share with you an observation. So I don't have concrete data for this next slide, but here's an observation. My observation is the more junior you are, the more you like complexity. And this was, so as part of, as an aside, as part of being a Sequoia investee company, I have access to any other Sequoia investee company is a phone call away. So I actually sat down with the VP of Google that ran, he just retired, their engineering department. This guy has like 6,000 developers reporting to him. And we were talking about it. And his comment was that junior developers want to prove to you that they're smart. And so how do they prove to you that they're smart? Well, they prove to you that they're smart by making something so damn complicated because you'll go, wow, they're smart. And that was just, so that meshed with my picture. Because until you get comfortable in your own skin, until the junior developers, and we were all junior once, and we may even have a few in this room, until you get comfortable to be able to say that solution is too complicated, you don't get to a point where you can actually start making decisions to help your company out. I purposely didn't put a time at the bottom because I don't really know, and it's very individual dependent. I know people that have been in the industry for 20 years that are probably here, And I know people that have been in the industry for 5 years that are here. It's very, very independent of the individual. But I will assure you, everybody in this room, except for the non-technical people that I know that are sitting here, is going to go through this curve. Guaranteed. And you will go through the curve because, A, you get older like me, and just thinking through the complex problems just makes your head hurt. You just want simple. You stop having to prove you're smart. It's hard. When you're sitting down in front of a 21-year-old developer, just graduated, top of his class, University of Waterloo, University of Toronto, pick your favorite university, all they want to do is say, I'm brilliant. And if you don't give them outlets for them to be able to tell you that they're brilliant without screwing up your code base, they're going to screw up your code base. This chart it's one of those things that if I had this chart when I started growing up in the development and architecture ranks, I would have hit that curve much sooner. Because ultimately, we're all smart. We're all smart in different ways. We all bring different things to the table. But if you're in an environment where you have to continually prove to your boss, your team lead, your CTO, VP, CEO, that you're smart, you're in the wrong job. You shouldn't have to prove that you're smart by making something so complicated that only you understand. That is not the way to prove you're smart. The way you prove you're smart is by scaling your company to a point that we just launched 200,000 people on our platform and nobody noticed. That's smart. I got a bunch of smart people working for me. And they're smart because they don't have to prove to me that they're smart. Because I know they are. So the faster you get past this, the better. So that ends complexity. Next is, I'm sure, where everybody's expecting there to be scalability problems, the database. Ah, yes, the database. So back in 2009, up until when we shut down the platform, we had ORM. ORMs make you stupid. Kidding. No, I'm not. You need to understand your data. Do not let the ORM define your schema. Do not let the ORM control your database. Generating reports out of ORMs is painful. Painful, painful, painful. The first brick wall we hit was somebody trying to generate a report, and it took everything out. Because ORMs do not access the data in ways that make reporting easy. Now, this is something I firmly, firmly believe, that developers must understand how a database works. And I also find that a lot of junior developers, and this can go right up to senior depending on how much of the ORM virus you have in your blood, do not understand how databases work. They are viewed as dumb repositories. People spend their lives making databases bigger, faster, smarter. There is something there. Understand what it is. You still may love your ORM, and I'm not telling you to give away your love, but at least understand how ORMs work. Because there may be a few of you, I didn't see very many Java hands, so it's, I might be safe tonight, that are saying, yeah, but ORMs, can they scale? Sure. No doubt about it. Is it hard? Oh yeah. I did a quick Google. Just quick Google, how do you scale Hibernate? Right, we were using Hibernate, how do you Hibernate? Number one, number two answer was something from Stack Overflow. And this was the quote. And I quote, "A good ORM will provide plenty of hooks that allow you to optimize quite a bit. You just need to spend some time learning it." Awesome. That's all. I just got to spend some time learning it. This is wonderful. Scenario time. Your system runs into a brick wall, your customers are complaining, they're bitching at your CEO's in the CTO's office, you can hear him yelling, the VP engineering is in the corner, curled up, he's in a ball, they come out, they're all looking at you and they're saying, how do we scale this? What do we do? Well, it's obvious, all we need to do is just learn all the hooks. What? That doesn't make any sense to me. If you don't know how you're going to scale your ORM system today, why did you start with it? Why?
Ignorance.
Why? And you started with it because, well, it kind of like it goes fast and I can write code quickly and it's wonderful. You just got to learn it. I haven't met a CEO that has patience yet. And if you tell your CEO, I need to take a course. It's a 3-day course. It's on Hibernate. It's actually Hibernate level 1. I'm just going to be a junior Hibernate guy. But there's an intermediate and senior. Don't worry. 6 months, I'm going to be a Java certified Hibernate Guru Master Ninja. We'll get scaling nailed then. Yeah, I'm pretty sure you're going to be looking for work. I had one person, this last quote, 100% true. I'm in there, I'm going, this isn't going to scale. We can't scale with Hibernate. The way you've built it, it's impossible. It's like, I get the hooks. Nobody in this company knows. I can't hire anybody. Straight-faced. We just have to write the ORM into a new version of the ORM that solves all our scalability problems. Are you kidding me? I'm going to change one problem for a different flavor of the same problem? Can you make it work? Yeah, of course you can. Have people made it work? Of course they have. Can you make it work? I'm betting against you. It's the old line, somebody has to win the lottery. Except that person is not you. You can do it. I'm not saying if you are in a company that uses an ORM, you're sitting there and you're about to throw something at me, don't throw it at me. It's a little bit tongue-in-cheek, but it is, I'm being very, very serious. If you are working with ORM technology today, and you do not understand today how you're going to scale when your load on your database goes up by a factor of 10, I would stop what you're doing and figure that out first. Because when you need to figure it out, you are not going to have the time. So you need to know your database. I believe the database should own all the data. It's got to be your repository. It's got to be authoritative. Let it do what it's good at. Because if you do that, and you do run into that wall, a very simple master-slave configuration with a little bit of code changes, and I do mean a little bit, at least get your reading off of the replica. It's not going to solve your problems, but it may buy you some time. And if it can buy you some time to figure it out, then that's what you want to do. The other way to look at this is scaling your database is a well-understood problem. It's understood. Please don't confuse understood with easy. It is not easy, but it's understood. And there's only, I'm going to say, 5 different ways of doing it. I can't name all 5 because I can only think of 2 right now, but there's not that many. But you can go online tonight, type in scaling MySQL database. And I'm willing to bet you you'll have 10 awesome articles that will tell you everything you need to know about how to scale your database. Didn't say it was easy, I said you'll know how to do it. That is totally different than typing in scaling Hibernate. Good luck on that one. So let's talk about sessions. So server-side sessions are great. They're very developer-friendly. But if you store server-side sessions, you only have 2 choices to scale. 2, exactly 2. Session replication and sticky sessions. Session replication is yuck. If this is your preferred route to scaling, yuck. This will work with 2 machines, 3 machines, maybe 4, maybe 5. Okay, I'll give you 10. You won't get to 10, but I'll give you 10. What happens when we need that 11th one? This doesn't work. Session replication is very chatty on the network. And chatty on the network means under times of heavy load, what happens to your network traffic? It goes up. It goes up pretty fast. So what ends up happening for your users? Well, the user gets logged out magically because your session hasn't yet been replicated to all of your other servers. I highly discourage session replication as a method of scaling. You can make it work in small environments, and depending on your configuration, it might work for you. But in a multi-tenant platform where we are trying to scale one infrastructure, this just does not work. Sticky sessions. So this is the other alternative. So sticky sessions are where you tell your load balancer, when you see this request, send it over here. And that way the session is always in memory. So this does work. Used this in the past. It does have some not great properties. One property is that if the machine fails, everybody that was logged into that machine has now been logged out. So you get a little bit of a bad user experience. But you need to be very careful when you configure in your load balancer. Or you will have all the IP addresses of one company will go to one server. So you actually then do not get any benefits, because for us, we have 160 companies. They come out of 160 IP addresses because everybody proxies their corporate data, which means that one company, so CVS Caremark, 200,000 employees, would hit one server. That server isn't going to make it. So be careful. One of the funny stories I had 2 jobs ago, we had sticky sessions. We had a customer for it was probably maybe days, could even have been a week. He's like, your site is down. We'd go on, no it's not. You're stupid, must be your internet connection, using dial-up, like what's the problem? Well, did we all forget that we had sticky sessions? They were hitting a server that actually was down. Our corporate address was actually hitting a server that actually was up. So when we actually tried to do anything, it worked. None of our monitoring tools picked it up because our monitoring tools said the machine was up, and really it was up. It's just that the process was not being responsive. So be careful with sticky sessions. They do work. In a pinch, you can get there. That now brings me to caching. So caching is an important quality. And the problem always is when to cache. So our platform back in 2009 made extensive use of caches. Extensive. So the knee-jerk reaction is to say, well, that's a good thing. But it wasn't in our case. And so this is the downside of caching. And it wasn't because caching was used as a performance enhancement. Caching was not used as a scalability enhancement. Those two are two different things. And you need to understand the difference, or you will make the same mistakes we did. When you're caching in your application because your application can't go fast enough, that's a problem. Because now you have the equivalent of server state because your cache is holding data. So now you introduce another machine. How do you sync the states up? That's a problem. If you need to cache for performance reasons, you need to look at your architecture again. You're going to have problems scaling. So the first step is admitting you have a problem. And this is really hard. It is really hard, especially as the new guy coming in. You can talk to Zach, who was the MC up here. He was one of the original members. It's hard. You've been working on this thing for so long, and here's a new guy saying, wow, I don't get this. This is going to be a problem here. That's going to be a problem here. But you have to understand, never fall in love with your technology. If you fall in love with your technology, it's going to break your heart. It's not going to love you back. You're going to give it everything, and it's going to give you nothing. You're going to want it to be a doctor when it grows up, and it's going to drive a truck. Like, it's just, it's not going to work for you. It's hard to let go of your baby. If you view your technology and you cry when it's upset, that's a problem. You have to let go. It's just ones and zeros. If I can't walk into your company tomorrow, not that I would because you'd probably get me arrested, and I can't delete your code base and you go, yeah, I can write it better. If that's not your immediate response, you're in love with your technology, stop that. That's bad. Because if you're in love with your technology, you can't make the hard choices. And the hard choices are what's going to separate you from your competition. The journey. So it's been a while for me to get to this next slide. Because remember that complexity curve I showed you? You have to actually get pretty far along the complexity curve to hit this next slide. And that's what a web application is. Web application is 5 steps. And they are so simple, even the HR ladies in the back who are sitting giggling and having a great old time out there can understand these five points. Number 1, the user makes a request. You validate that request. You grab some data, you divide it by 2, 3, multiply it by 47, you put it on a web page, and you send it back to the user. That's all a web app is. No more, no less. If you can't make that go fast, that's a problem. Where do people get messed up? They get messed up because they view number 4, and actually number 3 and 4 kind of together, as, wow, this is my time to architect. I am going to architect a solution that is going to be the envy of everybody in Silicon Valley. People will pay homage to my architecture. No, you're grabbing some data from a database, you're putting it in a damn web page, and you're sending it to the user. If you have that as your mentality, you will write good, scalable web applications. If you view it as more than that, you will write very complex, not so scalable web applications. So what were our guiding principles? First of all, we were starting our deployment on 3 machines. Starting. Why? Because we wanted to know if it's going to work right out of the gate or not. By starting your deployment and your production pushes on 1 machine, you can make very subtle design choices that mean you can't add the second one. So if you don't start with more than 1 machine, I suggest you're going to have more problems than if you do. And now you can sit there and go, well, why not 2? Why 3? Well, it's just one of the things that I find that you can still get away with some optimizations for 2, but as soon as you add the 3rd, you really have to think about the problem. So 3. That was going to be our minimum initial deployment. So the second one, you can argue with me one way or another, if this is just a personal preference, our servers had to be stateless. I wanted the load balancer to simply do round-robin load balancing. No sticky sessions, no cache coherence problems, nothing. I wanted them stateless. The database owns all the data. So one of the things that I personally despise about Hibernate, but one of my developers said, yeah, but you can do this, that. Okay, it's fine, I got it, is that Hibernate caches for you. As soon as you take data out of the database and cache it above the database, you end up having a whole bunch of problems around cache coherence, replication, who owns the data, who's going to update the data, how do you lock when you're doing a big transaction. Yes, they've all been solved, I get it. But if I can't understand them in 20 seconds, it's too complicated. Remember, it's 2 a.m. and I need to understand why this transaction isn't going through. I want to see begin transaction, whole bunch of SQL, end transaction. I don't want to see random stuff. Caching has to be an explicit choice. We just recently, less than a month ago actually, believe, we added memcached. I'll show you our architecture picture in a second. So memcached, for the people who don't know, is a high-performance caching engine. Why did we just add it a month ago? Because it wasn't a problem until a month ago. It was an explicit choice. We did not need caching to achieve levels of performance. We are using caching to achieve levels of scalability. Always use the right tool for the right job, and I'll talk a little bit about this in a second. We don't try to force things in. If the right tool is something that's, hey, we got to go deploy some more infrastructure, we will do it, but it has to be the right tool. And finally, minimize complexity. We had a bunch of other goals. So we wanted zero downtime deployments. So yes, I know Java, you can make it work with zero downtime deployments. We never managed to figure it out. So I wanted to be able to push code to production and not have to tell anybody. Now our account managers really hate that because something bad happens and their account thinks our platform is really buggy, and I'm looking at you, Paula. Yes, but the ability to push code to production and not have to tell anybody to fix issues on the fly without taking the system down, huge win. And we also wanted to maximize developer productivity. So we came up with our target. What is our architecture? This is the equivalent of that J2E architecture that I showed you earlier. Because every scalable web property on the planet will draw you this picture. Why will I draw you this picture? Because this is how you scale a web application. So chicken and egg here. We have a load balancer out in front. We have a whole bunch of web servers. We have a memcached cluster. We have a network attached storage device that we use as a shared file system. We have master-slave MySQL, and we have a bunch of machines for background processing. So that is our architecture. That's our architecture today. And how do we scale? It's those little dotted lines, and eventually down here our slaves will have read replicas where we have clusters of read slaves. Well understood scaling properties. And if you're interested in scalability, I don't want to say this is the gold standard because maybe somebody's come up with something better, but every property that I have seen that has high traffic that you guys would know names to has an architecture that is very similar to this. And why? Because every component in this architecture does one thing and does one thing really, really well. We don't try to jam anything together. So now let me get to what, depending on the audience makeup, would have been a very contentious discussion, or it could be just an educational one. I'm hoping on the educational. The choice of language. So we were a Java shop. We were a Java shop for many years before I got here, and we were a Java shop for a year and a half or so, maybe 2 years after I got here. Then we moved. Why did we move? We picked PHP. Why? Because PHP has the fastest debug write code cycles there is. Okay, yeah, maybe Python, maybe Ruby on Rails. I get it. It's a scripting language. It has fast cycles in order for you to write code quickly. The zero downtime deployments come for free. So that's one thing I don't have to worry about. I don't need, in the Java world, a Java expert to come and tell me how to orchestrate a orderly shutdown of servers in a row so that I can get code deployed in really weird ways. So it happens for free. And the final point to me is the most important. Because remember right at the beginning I said, it's about the design decisions that your developers make in the middle of the night that are going to kill you. In PHP, it is very difficult, I'm going to go with almost impossible unless you really try, to have server-side state. You can do it, but that one decision solves a ton of problems. So the non-PHP people in the audience are sitting there going, but doesn't PHP suck? Well, languages don't suck, only the developers that use them do. PHP isn't perfect. If you want an exhaustive list and a few rants and flame wars and a whole bunch of entertainment, just Google why PHP sucks. You can't sleep. It's great reading. But PHP doesn't scale. Really? Languages don't scale, architectures do. If you don't believe me, ask Wikipedia, ask Facebook, ask Dig. All of these companies have managed to build traffic that, unfortunately is going to be bigger than almost everybody's in this room, unless Facebook decides to go away tomorrow. If they can make it work, you can make it work. It's an interesting exercise to think of the number of PHP properties that you know of that are high growth, high performing, high traffic, and the number of Java ones. Who can give me what is the highest Java one? Who knows?
The sports one? Amazon?
Amazon. Right? So Amazon, they made it work. So everything I said, I never once did I say Java doesn't scale, J2E sucks. You know, we can have an interesting debate whether it does or doesn't. You can make it work. It's a question of effort. Then the other one I always hear is, sure, but PHP slow. Yes, it is. But if your application is not database bound, you didn't write your application right. Our web servers, Scott, web servers percentage?
15, 20%.
15-20%. Our database server, excluding today?
30 to 40.
Thank you. Today it was double that. Right? So we are database bound. When production has problems, it is never because of PHP. It is always because something happened in the database. A table got locked, got left, so we were queuing requests. Something in the database. Performance is important, but it is not your limiting factor. When you're the size of Facebook, yeah, it's a problem, because getting 10% performance means you drop 10,000 servers. 10,000 servers is a lot of money. When you're our size, 10% performance buys you 1% of CPU. Whatever. Completely irrelevant. Yes, but there has to be downsides, right? Yes. PHP is arguably a screwed up language.
It's a pretty hacky project.
It's a pretty hacky project, right? Where it started, where it is, it's kind of stunning that some of the largest sites on the planet are using it. It has some basic flaws, but if you're aware of them, you can get around them. It is not your limiting factor. It is not going to be the reason why you fail. Coding standards are a must. Error handling, detection, reporting, handling are critical. Our plan is to do this type of talk on what we have done. But I encourage you, if you're a PHP shop, make sure you have rigid coding standards. I know for us at the beginning we didn't, and now we have to go back and clean up some of the messes that we made. Okay, it's a mistake that we made. And one of our favorite religious wars is, where should brackets go? Oh, we don't want to start that one. We could easily spend hours on where brackets should go. The next question, once you pick a language, is picking a framework. We use CodeIgniter. We use CodeIgniter simply because it's understandable. You can look at the source code, and in a couple hours, you will understand every line of that code. But it's a standard MVC MVC framework. It follows the open-close principle. It's infinitely extensible without having to modify any of the source code. And as long as you know PHP, you need to know nothing else to use CodeIgniter. When I look at Java, you can know Java, you know a little bit more before you start writing servlets and servlet containers. You need to understand the whole Java ecosystem. Find .NET's a little bit better, but it's still similar. You need to get your head wrapped around a lot of stuff before you start writing those applications. Once again, lots of people do it. I'm not saying that's a bad thing. I'm just saying it is an issue, and you just need to be aware of it. Using the right tool for the right job. So it's kind of funny how this one is kind of weird. I've been in lots of places where we argue who should serve static content. And it always comes down to, well, static content is static. Let the web server do it. Now, when you're using a Java platform, sometimes it is easier to let Java, or not, it's not Java serving it up, it's a servlet container serving it up. It's not the right tool. Because if you have Apache serve up your static content, you can move all your static content off of your main dynamic pages, stick them in a corner somewhere, have a nice clustered environment, high performance, and it's serving out static content. So just put your content in the right places. We have a network attached storage device. It's actually fiber connected, so we have nice bandwidth to our boxes. If you're on EC2, you obviously can't do this, even though I'm sure that Amazon probably does have fiber connected storage. And this is because we wanted a shared file system. So we have a network attached storage device. It is redundant, and it allows us to have known places in the file system where we can put things. So we don't have to continually query the database to find out where a file is. We know where the file path is. We just go grab it. And we have background boxes. Back in the old platform, we would run all our background processing on our web server box. Remember, we had only one web server box. So just moving all of the background jobs onto other machines, even that bought us more performance and more scalability because it allows us to control things in a completely different way. So what problem did we face? We had 120 customers. We had to migrate them to the new infrastructure. So how did we do that? And this is actually, I'm very proud of what we did here because to our customers, they did not know what we were doing. So the migration process. Step one is we wrote a servlet that passed requests off to PHP. So we actually had another instance over here. Requests would hit the Java controller. We would forward the request off to PHP. PHP would generate the page, and it would come back out. That allowed us to continue developing features, but have it appear in the old platform. So I don't remember which one of the developers came up with this idea. Brilliant idea. It allowed us the time to figure out what we should do, how we should do it. It just bought us breathing room. The second step was we had to start migrating customers to a new platform. So the way we'd handle that is we put a proxy server, remember that one box? We put a proxy server right in front of it, and as the request came in, we would farm it off to the old platform or to the new platform, depending on if you were on the old or new platforms. So this, once again, allowed us, it bought us time. As we migrated customers, we tried to migrate customers that had the feature sets that we'd had developed in the new platform and not the feature sets that we didn't. In hindsight, in retrospect, looking back, I can think of 20 things I would do differently. But at the time, it actually helped us and bought us a lot. So what was the setup? We had HA Proxy. HA Proxy is a wonderful tool. I'll talk about it in a second. And it separated the requests into the old Express platform and our new Achievers platform, and they both use the same database. So that allows us to pick up a program, client of ours, from the old platform, configure HA Proxy, and it'll flip over to the Achievers platform. So we did that for 4 or 6 months. We did customers slowly, one at a time, then we do them in bunches, and then we got bored and just did them all right at the end. But it allowed us the time and flexibility to do what we needed to do while keeping our customers happy. So HA Proxy, if you don't know what it is, you've never used it, if you're going to do one thing after this talk, go download HA Proxy and read about it. It is a wonderful tool. We have it in production right now. We have used it to take certain traffic off of our main production sites and move it to a debug server where we have better tools to analyze the traffic. When we're done, we flip HA Proxy back and it hits our production site again. This has saved us countless times when something is happening and you just don't know what's going on. You don't want to put all your debugging tools and everything on your production boxes. So we have one box that our IT guys have secured so nobody can break in, because if you broke in, there's all source codes there, there's a whole bunch of stuff there that we don't want you to see. But it allows us to move things over so we can figure out what's going on and then move it back into production. So we did it. It took us 6 months to migrate everybody. I would say our productivity has improved. Don't want to say it's a panacea. We do have some issues, like I talked about the coding standards, that we didn't implement those early enough. There are things we're cleaning up. There are even things that we're learning today. But we know our architecture can handle the load. And today was a great test for us. Dropping 200,000 people into our architecture, onto our platform, and having it work, that was a great feeling. Were we nervous? Absolutely, because until you get there, you just don't know. but we convinced ourselves today that what we did was great and it's going to work in the short term. We already know what some of the issues are as we go forward, and we'll have to relook at them again. And as long as we don't fall in love with our technology, we'll be able to make those changes. So some conclusions. Scaling is hard. But don't make it hard on yourself. Don't make it harder than it has to be. Reduce your complexity. Understand your database. And think about upfront how you're going to scale. If you don't know how you're going to scale, I would suggest you stop, take a couple of days, and figure it out. At the very least, it'll be eye-opening, and you may go, I rock, and this is great, no problems. Or you may go, holy mackerel, what are we going to do here? There actually is a problem. But knowing about it is half the battle. And finally, never let anybody tell you a language or framework doesn't scale. It's all in the details. You can make assembly scale. I wouldn't want to, but you can do it. It's all in the details. Thank you very much. So we have a couple of minutes for questions. If anybody has any questions for me now, otherwise I'll be mingling and asking. You can ask me questions after. Oh, Zach, Mark.
Okay.
Yeah.
My question is, how do you plan to scale database rights?
It's a great question. So the question was, how do we plan to scale database rights? So right now, our read-to-write ratio, I haven't looked at it in a while, but I would say it's probably 100 to 1. So database rights are not a problem in the short term. Our database reads are going to be our next big challenge. Right before we came out here, we were talking about what we're going to do about database reads. So for that, we're going to have our read slaves clustered, and we're going to distribute load across our read slaves. When it comes time to scaling database rights, we're going to move to a sharding architecture, which we've already talked about, where individual programs will be on their own database so that we can distribute write load. Because of our product and the way that we sell it, we can move whole companies out. So it's one of the things that allows us to scale our rights is that we don't have to worry about which database you're going to hit. We know you're from company X, we move you over here immediately. So sharding for the writes, clustering for the reads. Yep.
Any other major scalability hurdles that you see other than solving the database write and read problems? So
the one that we are currently facing right now and we're looking at is our newsfeed. So our newsfeed, as you saw just in the quick screen cap, and the reason that that's becoming a scalability issue for us right now is because we have a very robust access control model. So being able to apply all the access control rules to the database is what's causing us problems. We already have lots of ideas and we know what we're going to do there, but because our objects are simple, and I mean by simple, once again, do not confuse simple with easy. We understand all of the objects in our system, so when one of them starts to run into problems, we know exactly what needs to happen. Everything is visible, everything is open, so that we can go in, we can measure, and we can make changes. Yeah?
Why did you choose MySQL instead of, say, Postgres or MS SQL?
So that's a great question. The question was, why did we pick MySQL over Postgres? Or what was the other one?
MS SQL.
MS SQL. So we didn't pick Microsoft because we're not a Microsoft shop. In terms of Postgres versus MySQL, when I showed up, we were using MySQL already, and there was no reason for us to move off of MySQL. I find that most database, we spend most of our time in the database doing selects, getting data out of the database, and then it's the scalability properties that are interesting. So when I look at how can we scale MySQL, there's a lot of examples. There's a lot of people I can talk to. So that wasn't my problem. There wasn't any issues in terms of the database to move off of MySQL. Yes?
How much instrumentation or logging do you use?
Oh yeah, we have way too much logging. Oh, sorry. The question was how much instrumentation and logging do we have in our system? That actually is one of our issues right now. So when Zach asked, it's not a scalability issue, but it's actually a performance issue because we've logged so much data that we noticed, when was it, like a month ago, 2 months ago, where our load on our web servers was going really high. And we're like, why is our load going up? And it's because we were logging so much data that it was actually affecting performance. So we are still struggling to find the right balance between logging so that we can figure out what happens when a problem occurs and logging too much that actually impacts performance. So that one is still, we're trying to dial it in. Yes?
Do you have any numbers off the top of your head of how many queries your database is handling?
Yep.
And if performance has always been consistent or it's fluctuated depending on the number of queries?
Okay, so the question, sorry?
The number from today was 1,500 a second.
Yeah, so the question was on performance numbers from our database, and the answer, thank you, Zach, was we were doing 1,500 queries a second today.
And the performance was?
The performance was, so I'm biased, so let's ask how was the performance today in the system? Is it okay? Normal. Yeah, so we were processing, 4.3 million rows a second?
Yeah, we're doing about between 4.3 and 5.5 million rows read per second and about 1,500 queries per second.
So that was 4.3 million to 5.5 million rows a second in terms of reads.
Thanks.
Yeah.
You explained why you chose PHP, but what are some of the reasons you decided to go against, say, Ruby or even ASP, C#, .NET?
So Ruby, I'll start with Ruby. So I actually have Ruby experience in my background. And while Ruby has a lot of strengths, the sheer amount of magic in Ruby on Rails was actually an issue for me. So this is a true story. I'm a day into my job as CTO at ZipLocal. We were a Ruby shop. We had a production problem. I'm like, not CTO, I'm going to go fix this production problem. I'm looking at the controller, and I'm like, well, it's impossible. There's nothing in this controller. And oh, wow, because if you call your file the right thing, it loads the model automatically. And if you call this file the right thing, it loads helpers automatically. That's wonderful once you get to understand it all, but until you get to a point where you understand how Ruby on Rails is put together, it becomes a nightmare for the poor developer. Second of all, we couldn't hire anybody. Hiring Ruby developers, so I would interview people. It would be, I'd say, well, okay, you're a Ruby developer. Yeah, and they go, yeah, give me your experience. Well, I read a book. Not a Ruby developer, it's a guy who read a book. So hiring Ruby developers was the #1 reason we actually moved away from Ruby. And I didn't even consider it to go from PHP. C#, it was just too much of a mind shift for the organization where we were at. Like, it was hard enough to get people to think that PHP was a viable language. Having them go to the dark side was just, that would have been impossible. So the only viable options were really Java and PHP. We could have stayed with Java, so I have nothing against Java. Java is a wonderful language. The issue is one more of organizationally. If you have a code base and you're under time pressure, you're tempted to go back and grab something from that code base. And I wanted a clear break of the way that code was put together. And so the only way to get that clear break was to actually go to a different language. There was a question, yeah?
Does your application have any scenarios where you might need transactional integrity across a series of HTTP transactions where you necessarily can't share state? Did you have a strategy for dealing with that?
So I actually don't think we do. Oh, so the question was, do we have any scenarios where we needed transactional integrity across a series of HTTP transactions? I can't think of any. You guys think of, I don't think we have any. We have forms where there are multi-state forms, but nothing that needs transactional integrity across all of them. Clearly, we have the transaction being done at the end, but I can't think of one. You guys think of?
Yeah, like product uploads. There are times where you have to write an attempt file.
Yes, okay. There are cases where it's the transactional integrity isn't across multiple HTTP requests, but it's across multiple back-end processes that have to happen. And so in those, we do a lot of pre-flighting of work to get work all set up so that when we do run the transaction that we can run it in one shot.
There's also split transactions across vendor integration, like Expedia, Ticket Jones.
Yep. So we do have, so I think so Matt, who just answered that question, was the one that did the Expedia and Ticket Jones integrations. So I can make it up, but he'll at least tell you what the truth is. Any other questions? Yes? So we currently, let me think, do not have any single points of failure. Scott? Good answer. We do not have any single points of failure. Yeah. So Q9 actually gives us 2 redundant network connections that are plugged into 2 switches or 2 firewalls, right? And then everything behind it has redundancy. So we have no single points of failure. That's how it was built. I was just testing. Yeah.
What about your MySQL database?
In terms of,
Single point of failure.
so we do have read slave. So we have master slave set up and we can fail over to the slave.
So slave leg isn't an issue there?
So almost instantaneous. Yes?
You mentioned you're sending a large amount of emails. Is this something you're doing in-house or with a third party?
So the question was, we're sending a lot of emails. Do we do it in-house or do we use a third party? We do everything in-house. So we have our own mail queue processing that happens, and we drain the queues as fast as they get filled. Yes?
One of the benefits of Amazon is that it has those, simple queuing service and email sending service. Did you use any of those, and you have to build your own afterward? And what's wrong with that?
Great question. So one of the issues, I'm going to answer it slightly differently. So one of the issues that we had with Amazon and our customer base, so this may not be an issue for your customer base, but one of the issues that we had with our customer base is security around data. Our customers wanted assurances that their data was protected. It was hard enough to get them to understand that we were using a cloud infrastructure. I was on conference calls with, they will remain nameless, for hours and a half trying to explain that we actually didn't know where our server was. And that was one of those concepts that was so foreign that it took me an hour and a half to get them to the point where they kind of sort of almost understood that we didn't know where that server was. For me to then to turn around and tell them that, yeah, we don't know where their data is, that was a non-starter. And so security was one of the primary drivers for us even considering leaving Amazon. So that was kind of like, hey, security is a big issue. It's costing us a lot. We get more performance. Those were kind of the trifecta for us to actually move off of Amazon. So we looked. We actually we spun up some of them also, but we never went farther than experimenting with them. Yeah. One more question. Maybe 0 more questions. Well, thank you very much, everybody. We will be around for the next little while, so if you do have any further questions, please grab myself or anybody from the development team, and thank you very much for coming out.